Okay, so this is a difference of squares because it's a difference, a subtraction of two perfect squares. N squared is a perfect square and 4 is a perfect square. Kind of feel like deja vu for everybody, right? Okay. Now there's another way we could have done this problem. We could have used all of those rectangles that we've been looking at. So I'm going to draw a rectangle. If you don't really love the rainbows and smiley faces, you could have done it this way. I could say, okay, this is my length. So this is n plus 2. You know what? I'm going to draw a little line here. What is the distance from this point to this point? It's actually staring you in the face right now. N. That's right, Emerson. It is n. What is the distance from this point to this point? 2. 2. Okay. So we understand where we got the n and we got the plus 2. Right. Well, that means this could be the height. So let's say this is n minus 2. What is the distance from here to here? From here to here. N. Okay. What's the distance from here to here?
-2.
-2. All right. So let's try this. What is the area of this square right here? N squared, because it's n times n. Oh, look, we have n squared right here. What about this square right here?
-2n.
Oh, right, -2n. That happened right here. How about this square right here?
2n.
Because 2 times n is 2n. That happened right here. How about this square right here?
-4. -4.
It's almost like you knew what I was going to ask. That happened right here. So we could also multiply using this divided rectangle too, and actually tomorrow you're going to do a lot of that. But I want to talk about differences of squares and why they're so special. So I need a volunteer. Oh, Marley, thank you for volunteering. So Marley, what is your favorite color? Orange. All right. Marley, what is your favorite number? 7. So we have Marley plus 7 times Marley minus 7. So right now you have 30 seconds. I want you to multiply this out. I don't care which way you do it. Divided rectangle, rainbows and smiley faces, I don't care. Just multiply it. All right, Marley, what did you get? Okay.
Okay, on the problem above, I'm confused with where you got the -4.
Because 2 times -2 is -4. Or 2 times -2 is -4. So Marley, what is m times m?
M to the second power.
M to the second power. What is m times -7?
-7. Or, yeah, 47 m.
7 times m?
7 m. Or,
Yeah. 7 times -7? Positive or negative?
Negative.
Definitely negative. 7 times 7 is?
I'm so afraid
It's okay. It's okay. 7 times 7? Nothing's worse than being put on the spot.
49.
49. -49. All right. So what is -7m plus 7m?
M. Or wait,
If I have 7 m's and I take 7 m's away, what am I left with?
M. Sorry.
Don't worry, you're not the only one who has these questions. So I'm drawing 7 m's. Would you agree that I have 7 m's? Okay, so that's this 7m. I'm going to take 7 m's away.
Oh, 0.
I have 0. I have nothing. Okay, so these cancel out. So I'm just left with m squared minus 49. So these two expressions are equivalent. Let's work the opposite way. Let's see. I don't feel like I've heard from Emerson Cohen at all today. Emerson, how are you?
Tired, how are you?
Doing wonderful, thank you. All right, so let's say we have Emerson. Say we have Emerson squared minus 25. What is Emerson squared minus 25 going to be in factored form?
So, since e to the second is e times e, and then negative 25 is, well, 25 is 5 times 5, that's negative, so I don't, so it'd be e times 5 and then e times negative 5.
Not times, so in...
Oh, plus e plus 5 and e minus 5.
There we go. And this is for a special case of differences of squares. One more and then we'll let you go. They're actually pretty quick. So let's say we have, give me a name.
Oh, how about Alyssa?
Alyssa Nurmat. So we have Alyssa to the 4th minus 64 Nurmat to the 6th. So we have our differences of squares because a to the 4th is a perfect square. 64 and the 6th is a perfect square. We are subtracting them. So what are we going to get? And it doesn't have to be Alyssa, although I would love it to be Alyssa. Do I have any takers for this one to convert this?
No.
No?
Caleb has his hand up.
All right, Caleb.
Okay, so first you'd have to split the a to the 4th up. So you do a to the 2nd in one of the parentheses, and then the other a to the 2nd in the other.
Because a squared times a squared is a to the 4th. Okay, this is making sense. Okay, so now what?
And then you'd have to split the negative 64 up. So I think you do a squared plus 8 n to the 3rd.
Because n to the 3rd times n to the 3rd is n to the 6th, isn't it?
Yep.
And
And then the other side, you just subtract the 8 n to the 3rd.
congratulations, you just factored your first difference of squares. So really, you just take the square root of both terms, put them inside your binomial, and you're off and running. Just remember, one is positive and one's negative. All right, I hope you have a wonderful day.
Thank you, you too.
You're welcome.
Thank you.